11-10. I basically skipped because that kind of goes back, and the one that I did for 11-8 should be of assistance for that. It should be basically the same as long as you state your hypotheses, go through all again, use the 6th step. It says up at the top, use the 6-step hypothesis testing procedure for the following exercises. Okay, but when we get to 12, I'm gonna do both 9 and 11, which should help you with exercise 12. I'll kind of combine them here. But basically, let's look at 9. It just says, listed below are the 25 players on the opening day roster of the 2013 Yankees Major League Baseball team. Losers. Sort the players into 2 groups, pitchers and non-pitchers. Position players. Assume equal population standard deviations for the position players, which also means equal variances. So you know, as we go forward, I'll show you why. And the pitchers, test the hypothesis that the mean salaries of pitchers and non-pitchers are equal using the .01 significance level. So, of course, I would have to state, you know, the hypothesis is that they are equal, right? So that mu1 is equal to mu2, and then, of course, that they are unequal would be the alternate hypothesis. So away I go then, and I'm using the .01 significance level. Oh man, this looks like it would just be a pot full of work, and that's exactly right. So I'm going to show you perhaps a little easier way. When I said earlier, you know, hopefully you did the add-ins. If not, maybe see me or ask me about it to make sure that we do the add-ins that we have for Excel, because we're going to start using the data analysis. Okay, and so here we go. If we're here and we're at home, okay, but then you got to click on data, okay, and then click on data analysis. And I think you guys are going to find this as fun as I do, because sure, it will alleviate a lot of work. So remember I said we're assuming that the standard deviations were the same, and if they're the same, the variances are the same, right? Because standard deviation is just the square root of the variance. Okay, so we can assume equal variances, and we're doing a t-test, okay, to sample. Perfect. Okay, so I hit OK. Okay, now I got to do my variable range 1. Okay, wish I could do this a little bit different, but I'm going to have to do it like this. So my range 1, and these are my variables, is my salaries, right? Okay, my range 2, I've got to highlight like that, and I've got to move this out of the way so I can capture that. Okay, I probably should change these. It would be a little bit easier then. Hypothesize mean difference, you can leave blank. I'm not going to use labels in this case because I didn't have the right kind of labels up here. When I do the other one, I'll show you how to do that. But then it says the alpha, and the alpha relates to the significance level. Okay, and mine's wrong in here because my alpha says 0.1, and don't confuse that with the alpha that I'm asking for. That it's asking for is 2, or 0.01, right? Okay, 0.01 is the 0.01 significance level for number 9. Okay, my output range, you're probably going to get it. It's going to show up like this. Okay, and so click on output range. Yeah, okay. And let's highlight that, and I want it to show up here. Okay. I'll show you why, because hopefully it shows back up and puts all the numbers right where I want them down here. Oops, I got too many decimals in there. Now that's my problem. That's why it didn't like me. Okay, now I should be okay. Here we go. It shows all kinds of weird and funky numbers, right? Okay, but this is a two-tailed test, right? Because we were at equal or not equal. Okay, and so it does at 0.01 significance, but two-tailed. What's that mean? 0.495. Remember? Okay, and so if I looked that up, I'd come up with, 0.495, somewhere's in here, right? Right in between those two. So 257, right? 257. Okay. Oops. Somehow I got that wrong. 0.01. Ooh, 0.495. That should be right. How did I goof that up? I'm going to pause for a second and figure that out. Well, it's because I'm a moron, because it says right here I'm using the t-test, right? Okay, so dadgummit, there's 25 players on a team. They obviously have 12 pitchers, 13 position players. So remember, when we do 2, our degrees of freedom is the pooled, so 25, and I get 2 samples, so -2, so I got to go to my t. So I got 23. You know what's scary is I looked this up before I actually even started the video, and I still couldn't remember. Okay, and it's two-tailed, so we come down here where it's 0.1 and 23, 2.807. Must be getting about time for me to retire, which is what I have here, 2.807, and obviously the computer extends that out, a little bit. I got rid of my little funny, nice little thing, so I'm gonna put some nice little deals there, right? So that's, so I'm gonna reject if it's greater than 2.807, or I'm going to reject it if it's less than a -2.807. So it did the work for me. Okay, well then it went even a step further and it calculated what my t statistic is. Okay, and so my t statistic that I calculate, if I went through all the stuff, like you have to do normally, it would be 0.42. Well, is that greater than? Okay, is that greater than? No, it's not greater than, and it's not less than a -2.807. So therefore, I have to. I can't reject the null then, right? Okay, I cannot reject the null, because I would reject the null. By the way, you guys need to state all those things, right? I can't reject the null. Now it gives me my p stat for a two-tail is 0.67, so it's pretty large. Okay, it's actually a pretty large number. So when I interpret the results, I'm saying, well, actually there's a pretty reasonable chance. It doesn't look like it, but there's a pretty reasonable chance that it could fall outside of that. Does it ask me to do the p? Yeah, because I got to do the 6-step hypothesis. So there you have it. I'm going to see what it says for that in the back of the book. I want to make sure on my p-value that that's correct. It should be, give me 1 second. So for number 9, there's no difference in the mean salary, so it really doesn't even ask us then to do the p-value. Yeah, okay, well then forget the p-value in that case, because it doesn't ask for it. So do this, and then and go through the other stuff. Make sure that you're stating the hypotheses and doing the other things in the 6-step approach, right? That's earlier in the chapter. Now I'm going to go on to 1111 because it's very similar, but it gives us this data that we can download, right? And that's that gives us some sales and it gives us some audit. Okay, and so we're gonna do the same test here, right? Okay, and I should say, let's see, at the 0.1 significance level, can she conclude that the mean daily expenses are greater for the sales staff than for the audit staff? So that's I'm saying that's one-tailed then, right? Because I'm saying that the sales staff is greater than. Okay, so that would be my my alternate hypothesis, that the sales staff is greater than, okay, the audit. Okay, and my null hypothesis would be then that the sales staff is less than or equal to the audit. So I got to set that. I can come up. I can do my data analysis. I got a t-test, 2 sample, assuming an equal variance. I think it says it doesn't give me any difference, so I'm just going to say that we do assume that. I hit OK. Okay, now in this case, for my range 1, let's go ahead and include the sales. Okay. In range 2, let's go ahead and include the audit, but then come down and click on labels. Okay. It's not going to be a huge difference. My alpha changed, right? Because instead of 0.01, I'm at the 10%. Okay. And my output range, I'm going to put in here, right here. Okay. And hit OK. There you go. Now again, my one tail value, okay, I'm going to reject if it's greater than 1.36. So I'm determining what it asks, right? It says, can we conclude that the mean daily expenses are greater for the sales staff, or the sales staff, okay? So I'm going to reject it if it's greater than 1.363, right? And that's what it calculates here. My critical for my T-stat. My T-stat turns out to be, okay, 1.53. Okay. Hang on one second. And first I had to state my hypothesis, right? And this again, how you guys probably should type it out. The null is that mu1 is less than or equal to, right? Again, let's look at the alternate, because the question is, can she conclude that the mean daily expenses are greater for the sales staff than the audit staff? So I want my alternate is that mu1, okay, is greater than mu2. So my null is that mu1 is less than or equal to mu2. Okay, and then I look up the T-stat, or it does the T-stat for me, but we could look it up as well in the T-value, but it does it. Critical is 1.36. So I can come up later and then do that, and I can reject it if it's greater than 1.363. Okay. And so I run my deal here. It does all the work for me. My T-stat comes out to be 1.536, whatever that is. Okay, and here's my, and so I do in fact reject it, right? So I can reject the null and accept the alternate that in fact it does look like the mean daily expenses are greater for the sales staff than they are for the audit staff.